Handout? And you want to look at one that's cool with me?
Oh, Annie. You want my packet for number 6?
Huh? Oh, yes, number 6. Oh, aren't you smart?
I'm reading number 10 too. I don't know.
Thanks.
Of course I'm smart.
Alright.
Nice.
Smarter than you.
So let's look at number 1 again.
Give me my dad.
We're going to do number 1 all over.
This is the record mat over here. All steady.
And alright, you ready? Go ahead and start.
Oh, I've been recording for this whole time.
Okay. Alright, so how long have you been recording?
A minute.
Okay. Alright, so here we go. We got this limit as x
What
to
does lim stand for?
2. Huh?
What does lim stand for?
Limit.
And what does limit stand for?
The limit.
Yeah, but what's the limit? Is that what we're
Like
figuring out?
how far something can go. So like, say you're going on a date and your limit is to hold a hand, right? Or your limit is on the first date, the most I'm going to do is give a kiss on the cheek. So that's what a gentleman does, right? So that's your limit. That's as far as you're going to go on that day, right? On that day, meaning wherever we're going to. In this case, they want to go to the -2. They want to see what is the limit as we approach -2. Now, on these polynomials, we have to remember back to our rational polynomials last year. When we were doing them, we were working on, like, is there a hole? Do you remember when there was a hole, when something canceled something else out on top? There became a hole at that point, right? Or sometimes there was an asymptote, okay? And so we can look at this function right now. We can tell, is there a vertical asymptote? We know that there's no hole, there's nothing canceled. Okay, so is there a vertical asymptote? And it says up here, when the bottom equals 0, there's a vertical asymptote. So we know right away that this function right here has what we call a vertical asymptote. Right? And so that means, where is that at? When it hits 0. And when does this hit 0? When the function with respect to x is at -2. And when that hits, when we plug in a -2 in this function, -2 plus 2 is 0, right? And the bottom goes to 0, and that's undefined. And that's what happens, is it just blows up at that point. So at -2, there is no such point. So that's a limit. So we're going to look and see as we approach it. Now, if we take a look, it's asking us to approach it from the negative side. Okay? And that's what the negative up here at the top is. It's saying, as you approach this -2 from the negative side, this might be easier to read, right? You have a negative up here from the negative side. That means as we approach it from this side, what happens as we approach 2? Okay? So if I'm going to look at as we approach 2, it might be wise to look at -3 and -2 is -3 and -4.
Randy, can you move that bottle?
So if I plug in -3, what happens? So I look at -3 and I say, okay, I plug in -3, that's going to be 1 over -3 plus 2, which would be -1, right? So we would plug in, let's skip steps on this first one. -3 plus 2, and that would equal -3 plus 2 is -1, which is -1. So f of -3 is equal to -1. That is my coordinate. -3, -1. So at the coordinate -3, negative 1, that's my coordinate, that's a point, right? But I don't know in which way it's going, right? So I could plug in 3.5 or negative 2.5, negative 3. Well, that just makes it complicated, right? So let's plug in a nice easy number, which is negative 4.
I guess I don't have one.
Right? As we plug in negative 4, right, the function with respect to negative 4 is equal to 1 over negative 4 plus 2, which is just 1 over negative 2, which is just f of negative 4 is equal to negative 1/2. So my new point is negative 4, negative 1/2. Okay? So, when I look at this, now I know that it's coming from negative 1/2. So what that's telling me is that the function is going like this. And so it's going to start to dive down. And as it dives down, what's down here? But negative infinity. So where is it heading as it approaches this line? It's heading towards negative infinity. Does that make sense? A little bit. If we looked at the other side, we found yesterday that it's heading up to positive infinity.
Dan, do you have an extra notebook?
Yeah. And so that's something we're going to talk about on another problem.
I literally can't see.
So I'll just stop it right here. That's good.